Now let's look at our two centers of measure and talk about resistance. Resistance means that a measurement of data is not affected by outliers or extreme measures in your data. So if your data has, one very high point or one extremely low point, resistant means that it's not affected by that. So we're going to look at our resistance based on our mean and our median, our two measures of center. So let's look at this initial data set, and again, I just put them in order from least to greatest already, and let's calculate our mean first. So to do that, we need to add up our data points. So we've got 2 plus 2 plus 5 plus 5 plus 5 plus 8 plus 9 plus 9 plus 10, which gives me 55. And I need to divide that by 1, 2, 3, 4, 5, 6, 7, 8, 9 data points. So 55 divided by 9 gives me a mean of 6.1. Okay, now let's do the same for our median. Remember, our median is our middle point, so I'm going to find my middle point here, which looks like it's going to be at 5. I've got 1, 2, 3, 4 to the left, 1, 2, 3, 4 to the right, so my median is 5. And I'm going to erase that circle here for a minute because we're going to do some adjusting. So our mean is a little bit bigger than our median in this situation. So now let's alter our last point of our data set and give ourselves a big outlier. So instead of our last point being a 10, let's say when they conducted this study, one person measured in at a 20. Notice how that's quite a bit higher than the rest of the data points. So I would say 20 is a pretty good outlier, meaning it lies away from the rest of the data. So now let's do the same thing and let's calculate our mean of this set of data. So we're going to add them all back up. 2 plus 2 plus 5 plus 5 plus 5. Excuse me, I typed in the wrong number. 4 plus 15. There we go. 2 plus 2 plus 5 plus 5 plus 5 plus 8 plus 9 plus 9 plus 20. And I got a total of 65. And we didn't change the number of data points. All we did is we took our high number and pretended that did not exist, but we did have someone that measured a 20. So I'm going to divide that by 9 because I still have 9 data points. And my mean now becomes a 7.2. Notice what happens with that big outlier. That large outlier caused our mean to get larger, meaning the mean is non-resistant to outliers, meaning that large outliers are going to pull our mean in that direction. On the other hand, if I had a very low outlier, in this set of data it would be hard to have a low outlier, but if I had a really low number that was far away from the rest of the data, that low outlier would cause our mean to get much smaller. So it depends on which direction our outlier lies. But now let's look at our median of our data set. Again, we're pretending the 10 is not there. The person who measured a 10 actually measured a 20. And now let's find our middle point again. So there's still 4 to the left, 4 to the right. Notice that my median does not change. My median is resistant because it is not affected by those large outliers. That middle number is not going to change even if there's a really low outlier or a really high outlier. My median will always stay right in the middle of the data. Therefore, my median is resistant, my mean is not.